This is a brief introduction into everything you need to know before you start your A-level chemistry course. So it's basically looking at the key GCSE topics that I want you to be fully familiar with before you start the A-level. We're going to revise some A-level GCSE topics during the A-level. We will, remind you of things that you've got to know. But we really don't want to be spending too much time recapping the very basics. So this set of 3 videos or 4 videos is going to be a very brief recap of the basics. So we start off first with atomic structure and the periodic table, which is probably one of the first things you studied at GCSE. So what do we need to know? Well, first of all, let's just think about what atoms look like. And what we need to be totally familiar with is the crucial particles in an atom. So we've got our protons, we've got our neutrons, and we've got our electrons. And you need to know, of course, that protons have a charge of +1. Don't just say positive or 1, say +1. Neutrons, neutral, no charge. Electrons, -1. Protons have a mass of 1. 1 what? Don't worry about the units. They've got a mass of 1. Neutrons, they have a mass of 1. And electrons, their mass is so small we can usually forget about it. But some people remember the number 1/1840. So there we go. That's the mass of everything and the charge and their location. Well, of course, protons are in the nucleus. Neutrons are also in the nucleus. And electrons are in shells or orbits or energy levels if you prefer. And at A-level, we'll look at all this in a bit more detail. But for GCSE purposes, that's all you needed to know, and that's what we're going to start from. Okay, so what else do we need to know? Let's get back to our periodic table, and it's the protons in the nucleus that define the element. If I said to you, an atom has 8 protons, what is it? It's oxygen. It can't be anything else but oxygen. If someone said to me, what if an oxygen atom had 9 protons? I'd say, well, it's not oxygen, it's fluorine. So, the number of protons in the nucleus defines the element, and it cannot change. So, the number of protons cannot change. Next important thing to remember is that in a neutral atom, the number of protons and electrons has to be the same. It has to be the same. So, an atom of boron has atomic number 5 protons. It must have 5 electrons. The difference, though, being that electrons are in shells and the outer electrons can be lost or gained, or they can share with another atom. We'll come back to that in a later video. But if I've just got a neutral atom of any element, the number of electrons and protons is always the same. The third particle, the neutrons, they're not really that interesting. Chemists aren't really that interested in neutrons because if an atom gains or loses neutrons, which it does not do in any chemical reaction, by the way, it can only do that in a nuclear reaction, which needs extreme conditions like the temperature in the core of the sun or a nuclear bomb or whatever. The number of neutrons changing has no effect on the element. Carbon normally has 6 protons, 6 electrons, and 6 neutrons. But some carbon atoms have 7 neutrons, and they're what we call isotopes. And you just need to know the definition of an isotope. Much easier to remember the plural definition. Isotopes are atoms of the same element, Forgive my appalling handwriting, this is just a rough and ready video. Atoms of the same element, and that means same number of protons, but different number of neutrons. And neutrons don't affect the properties of an element, not the chemical properties. And so chemists don't really care if it's got 6 neutrons, 7 neutrons, 8 neutrons, an atom of carbon. We're only interested in the fact it's got 6 protons, so it has 6 electrons, and that's all we care about. Now, it's the electrons that really say how something is going to react. And if you remember, we have electrons arranged in shells. This is the Bohr model of the atom. You know, you might have 3 shells. If we take an element like sodium, sodium is element number 11. It's got 11 protons, so an atom of sodium has 11 electrons. Now, GCSE tip, I always tell my pupils, draw them in pairs. It's much easier and quicker to count them if you've drawn them in pairs. But there we are, sodium, element number 11. It's got 11 protons, so it's got 11 electrons. And of course, the protons give it an 11 plus charge on its nucleus. And the rules, remember, for electrons, maximum of 2 in the first shell, maximum of 8 in the second shell. Now the third shell, most people learn it as 8. It can be 18 in the third shell. At GCSE, that 18 isn't important. At A level, we start to look at the transition metals, the group in the middle here. GCSE, you might spend half a lesson on them at most. At A level, it's quite an important topic. And they have more than 8 in their third shell. And we also learn at A level, that you didn't do at GCSE, that quite a few atoms, when they bond, they do not have to have 8 electrons in their outer shell. There are a few molecules where an atom has fewer than 8 electrons, and there's quite a few where they have more than 8 electrons in their outer shell. That's something we cover at A level. Doesn't matter at this stage whether you understand that. You don't need to understand it until we do it at A level. But just to warn you that you will be meeting elements where having 8s in the outer shell is not necessarily what they always do. But at GCSE we learn atoms want to gain a full outer shell to be stable. So our sodium, with 1 electron in the third shell, wants to lose that electron. This brings us on to the second topic of bonding and structure, which I'll show you in the next video. Before I do, though, let's remember that when we have our periodic table, we can very quickly work out the arrangement of electrons in something, or the most important thing. We look at the group number, and that tells us how many electrons are in the outer shell. So carbon, group 4, 4 outer electrons. Fluorine, group 7, 7 outer electrons. And that's a great help to us because if we want to know how an atom is likely to react, we know group 1, they're likely to lose 1 outer electron. Group 7, they want 1 more to get 8, so they're likely to gain an electron. Group 4, 4 electrons. Do they want to lose 4 or do they want to gain 4? Well, we discover that they actually don't want to do either. They'd rather share electrons. That is in the next video. Okay, so very important, you know the group number tells you how many electrons are in the outer shell. And that underlines such an important part about A-level chemistry. So when I ask a class, what's the formula of magnesium chloride? They should immediately be able to tell me it's MgCl2. Why? Well, again, it's how it bonds, but magnesium's in group 2, has 2 electrons to give away. Chlorine's in group 7, only needs 1 to get a full outer shell. So immediately they can say, oh, it'll be MgCl2. We'll look at that in the bonding topic next.